All right, we just talked about nucleophilic addition, so let's talk about nucleophilic elimination, which is the counterpart to the nucleophilic addition. So let's go back to a species that has from an acid chloride, very similar to it. Or we have our oxygen, it's got a negative charge up here, and got a chloride. So, as you can imagine, this isn't a particularly stable configuration to have a negative charge located on this molecule. So, we will do an elimination step. So the negative charge, or the electrons from the oxygen, can come down and form a new bond in between the oxygen and this carbon in the middle here. Now when that happens, this carbon would have it already has 4 bonds to it, so we're trying to make a 5th bond. Well, we can't do that, so we need to have a leaving group. Well, the carbons are not going to want to leave, but this chloride could. So we're going to take the electrons from that bond and move it over to the chloride. So we'll get acetone, or propanone, if you're using the IUPAC name, plus chloride. And it's called nucleophilic elimination because we have eliminated a nucleophile. So this has now left the molecule. Let's look at another nucleophilic elimination. This time the nucleophile will be water. So there's our starting position for looking at the nucleophilic elimination step. And we've got a lone pair on the nitrogen right here. That will be important for this mechanism. So we'll have that moving in between the bond, between the nitrogen and the carbon right here to form a new bond. And when that happens, we have a particularly good leaving group right here, which is water. We'll have that move over. And then we'll form our product from this step. We'll just draw on the carbon there, double bond to the nitrogen. It's got 2 hydrogens on it, so now this nitrogen has 4 bonds, so it's going to have a positive charge on it now, plus water. This is a little bit more stable because now the positive charge is on a slightly less electronegative atom than the oxygen would be. So this is nucleophilic elimination. Again, we're eliminating a nucleophile. Now, these are just small pieces of actual reactions, but it's important to look at each little piece to see, oh, that's where that's coming in. So a lot of times we'll have nucleophilic addition followed by perhaps nucleophilic elimination. So this can be put together into a more complicated mechanism. We'll do that a little bit later in later videos.